He's going to talk about the year of ZK security. Welcome, David.
Yeah, thanks for the intro. Just a microphone check. Can you guys hear me in the back? Is that good? Like that? Everybody's complaining. Yeah. Good. Cool. So yeah, this is me, my persona, and I'm gonna talk about the year in review for ZK security. But before that, just sort of introduce what I'm talking about. I'm just going to talk a bit about myself. And so my journey started at NCT Group. Like 10 years ago, I was a consultant. I was doing traditional security, specifically cryptography audits. And I was auditing all sorts of cryptography, but not really cryptocurrencies because we're kind of like ignoring that part at the time. And I guess maybe this is relevant to this story, but at the time I really wanted to start a consulting firm of my own. And so I've been thinking about this for years. And from there, I sort of discovered ZK, or like general purpose ZK, with Zcash, when we audited Zcash. And I sort of got into cryptocurrencies, and I didn't really jump straight to the ZK, but I did some break, I'd say, at Libra/TM, where I stayed for 2 years, and then finally I went back into what I wanted to do, which was more like low-level zero-knowledge proofs, and I spent 2 years at Meetup. Not necessarily Meetup, at One Labs, which is the engineering company behind Meetup, but yeah. So I did some work at Meetup, and then 2 years after I left, and I created ZK Security. This was the landing page, and we did this. Or actually, next slide is better. We wrote that blog post almost a year ago, so our anniversary is very soon. And it was, I don't know if the names are here. The names are not here, but it was me. We had David, Brandon, and Gregor, ex-coworkers who are at Mina, and we all funded that together with the thesis that you don't have to read that, by the way, but with the thesis that we were seeing people using our stack. We had this kind of user circuits that like, people could use this thing called Snarky or O1JS now to write circuits, and we were seeing a lot of people writing bugs and writing like pretty, like having people were having trouble writing circuits, and so we're like, we think there's going to be a market for that. And if the smart contract security market is pretty big, then we think the ZK market ZK security market might get pretty big as well. So yeah, here we go. I'm here. This is a year after, and I'm here to talk basically about what happened after a year of doing these audits and what's up. So yeah, so I guess as a security consultant, the nice thing is that you sort of always go through the stack and you review a bunch of you always review a bunch of stuff. And I guess the bottom line for me was that after a year, I basically learned more than I learned in 2 years as an engineer at Mina. And the reason is that you're always looking at different things and like short-lived projects. Like you always spend like 2 weeks or 3 weeks learning something. And you're sort of on a time crunch, so you have to learn a lot of things like very rapidly. And you're reading white papers, looking at code, and it teaches you a lot of things. I'd say, yeah, being in ZK is kind of difficult because, you know, there's new proof systems and new frameworks and new projects every week or every day. So that's sort of been my life in the last year, learning a lot of things very quickly. So the situation when I started is I'm used to bad code. I was a consultant before, and my clients were kind of like throwing shitty code at me and way too much code, and I would find really bad bugs, and that was sort of my life. And I sort of hated my life to some extent because of the quality of the code, but you start learning how to ignore all of that. So I got into ZK. First client was like, oh my god, the code is great. The people are so nice. They have written like specifications and this doc, and everything's perfect. There's no way we're gonna find any bugs. And because I wasn't used to that, right? And well, it turns out we found a devastating bug. And so I'm like, okay, that's kind of interesting. That's kind of weird. So next client, like, okay, great code, great people, great specs, great documentation, and so on. Oh, we found a proof forgery. So every time this pattern kind of repeated itself for basically a year. I think we had like maybe one or two clients that we didn't really find like serious bugs on, and all the others were like pretty, like we found pretty bad bugs. And so that, to me that was very interesting because I was used to like very bad code, and here we have like excellent code, excellent, well specified, good people working things, and yet we're finding much heavier bugs, much worse bugs than what I'm used to finding. Like the sort of stuff I would find before was like if you manage to get here in the network and you can manipulate someone and maybe you like time the stuff, maybe you have an attack. Now we have like no, just forger proof, send it to the network, still a bunch of money. Right, and so yeah, probably you cannot read that from the back, but it's okay. I'll read it. But yeah, everybody writes bugs. That's something we know. After being in security for a while, you really get used to the fact that nobody knows how not to write bugs. And if somebody tells you that they don't write bugs, probably they don't really know themselves. But this is really true in ZK. We see a lot of bugs. Okay, so if you can read this is one of the examples. This is actually one of the first bugs that we found when we started auditing things. This is the Artworks R1CS framework. And they're implementing a nullifier, generation of a nullifier. So if you screw this up, you can basically double spend. And yeah, I was thinking maybe it'd be fun to like give you a bit of time. Can you guys read that in the back? So okay, I'll give you a bit of time. If someone can tell me like what's wrong with this code, then you get some points from me, social points.
Under constraint.
The what?
Is it under constraint?
It's under constraint, but can you see why? Or first part is right.
That's a variable under constraint.
20 more.
Authorization.
The what?
Where is the authorization?
What is what? Sorry.
The authorization key.
What key?
Oh, it's function. The second one.
The second argument? I don't remember, it doesn't matter.
Yeah.
Alright, I'll give you the answer and someone gets it in the next 5 seconds. So it's kind of hard to see, but now I can sort of screens and all of these code looks the same no matter the framework to me. And basically what's happening is that they pass some variable here. They get the value out of the variable. So they get an out of circuit value. They do a modular reduction of that value and then they reinsert it into the circuit. That new variable is called like new witness, or like there's different names depending on the frameworks. You're reinserting it here using a closure. And basically what's bad is that now that you reinserted the value in the circuit, the link is broken, right? Like you can reinsert whatever you want. So we call these kind of crimes boomerang. We have a blog post here on how we try to find more of these using tent analysis and fuzzing. But this one we found just by looking at it. And yeah, if you didn't get it, again, it's like you have a circuit variable, the variable in the circuit, you take it out of the circuit, you reinsert it, and now we have two different variables that are not linked together, right? In this instance, we can change whatever comes after, but we didn't do that. We actually changed what comes before. That's how we exploited that, and yeah. So that's an example I found was interesting because it kind of shows you like it's really a ZK bug. Like this doesn't exist in like other paradigms. Like you're not used to see these kind of bugs when you look at normal code, and it's really the kind of bug that only happens in ZK code bases. And it kind of shows like how difficult it is for developers to really get into that mind state. Okay, one last example. which also sort of shows something interesting. This is some circum code. This is also some bug that we found. I think this one is more obvious if you've written any circuits before. But oh yeah, anybody can tell me what's wrong with that? I guess it's a left shift of a 32 bits value. If you can read the. You're overflowing. No.
No.
Oh. It's only 3 lines of code. Get an ice cream if you find that. And if you don't know circum, it's going to be hard to.
Wait. Then it's using like single arrows. It's a sign, but like okay. So like part one you can I guess there's no constraint for the first line. It's just the assignment.
Right. So if you don't know circum, this is just an assignment. So this is like an out of circuit computation. Right.
So you can insert arbitrary value in R1 and R2 and still make the third constraint
Right.
satisfied, but actually you probably can overflow R1 and R2 and make it.
Yeah, exactly. So basically, what's happening here is that they do the shift, and they basically, it's a rotation. It's a shift. Rotation? It's a rotation, sorry. They do the rotation of circuits, and then they reinsert these things in the circuits, and they sort of constrain that to be equal to the initial inputs. But you can sort of do whatever you want here, actually. It's not properly constrained. You can just fix part 2 and then solve that equation for part 1. Or you can fix part 1 and then solve the equation for part 2. And I like this example also because it kind of shows you how developers think. Like as a developer, you just want to write something that works and you think that's enough. Like this is complete. Like you're never going to have any bugs if you use the circuit correctly. But it doesn't tell you anything about the security of it. And so you write something that works, you think it's enough, but no, you need to think about constraints. You need to think about things are properly constrained in this field arithmetic and so on. And so people are not used to that at all. So I guess one of the tools we wrote as part of that, actually that specific audit, we thought it was interesting that people didn't really understand that. So we wrote that tool called Circumscribe. You can use it if you want. I think the more experience you have, the less useful this is, but this is kind of a way to smooth developers into this kind of experience of writing circuits. And basically you write any circuit here, and it will highlight the lines that are involved in the constraints, and sort of show you like what the constraints are. And so as a developer, if you do that, I guess you get to see exactly what gets converted into constraints. The other thing that's interesting that we did also is a programming language to write circuits called NonM. Actually, Kata on my team is right here working on that as well. And it's kind of Rust-like, Golang-like. And we thought it would sort of avoid the kind of bugs that you have in these lower level tools where you can't really create your own types. You can't create abstractions, so users can create bugs very easily. And so with that, we have a stronger type system and all the nice things that come with a language like Rust. And the nice thing also is that we have this debug mode that tells you exactly what line of code created what constraints and why it created the constraints. And so here, this is a prompt backend. You can sort of see like, here you have a public input in this file. So we created generic gates, prompt gates. And why did we create this gate? Because we added a public input. Here you have an addition, so you have another generic gate. Here you have an assert equal, so you have another generic gate. And you can see exactly why, what's happening here, what kind of constraints we're creating. So, actually, we're working with Ethereum to improve that language. If you're interested, you can check the repo. Cool. So other issues that I can talk about that might be interesting. Application bugs and logic bugs are things that are always here, no matter what kind of applications you're looking at. You always have these kind of things. This is what I call yeah, I guess this is what I call like translation from like brain to code. And other things, the other things I was showing earlier were kind of like bugs that happen in translation between normal programs to ZK programs. Integration bugs, so it's interesting also like these proofs. When you verify a proof, it always takes public inputs. And these public inputs are usually not constrained as an optimization, so it's on you to constrain them. You have some bugs that arise because the public inputs can be bigger than the field size, and so you have valid public inputs that get reduced. That's a bug I wrote actually somewhere. And you also have the kind of bugs where you don't really sanitize the public input or do what you're supposed to do with the public input. Think of nullifiers or Merkle roots that you're supposed to like store or check or things like that. There's also a lot of proof system and proof composition bugs that we've seen in the last year. And so here you have to think of the lower layer. Like if user circuits are the layer above, here we're talking about the proof systems themselves. And here I would say the problems are that the papers are often vague. When you have a paper, it's kind of not straightforward to implement it. So it's not really like a spec. For example, Fiat Shamir is often underspecified, and we found a lot of Fiat Shamir bugs actually. And yeah, and so whenever people try to implement papers, they actually tend to implement things that don't look like the paper at all. They implement optimizations on top of that. They start finding different things that they can add. They write variants of the paper, and so it's often kind of hard to understand what actually was implemented just by looking at the paper. Okay, this is kind of a mean one, but academics are not always the greatest engineers. So this is not always the case, but sometimes things can happen because of that also. Cool, if you want to know more about these kind of bugs, we also collaborated on this systemization of knowledge paper. What don't we know? Understanding security vulnerabilities in starts. And this is a bit more thorough than the talk I'm giving right now. And this is part of also the research that we do at ZK Security. I don't know why I call that the dark stuff, but it's maybe like a kind of a, I mean, nothing I said earlier was kind of positive, I guess, or optimistic, but this is even worse, I guess. Okay, so whenever we look at ZK code, it's usually a pretty large code base. So the attack surface is pretty big, and the complexity is pretty high. And so usually for me, that's a recipe for bugs. If you want to create bugs, if you want to like grow bugs like mushrooms, just write a lot of code and write complex code. ZK is also applied to finance for the most part. We mostly see it in cryptocurrencies right now. And whenever you implement ZK, the circuits that you end up having are implementations of cryptographic algorithms. And at this point, I have a theory that if you implement something that's not a cryptographic algorithm, maybe it's not as useful, so maybe that's why. But basically what it means for us is that the combination of finance plus implementations of cryptography on top of cryptography increases the impact of the findings that we have. So yeah, lots of money and stuff like that. And not only that, not only the bugs that we find are usually devastating for the projects that we audit, but the fact that the ZK adds privacy means that sometimes these bugs can go undetected. So you have, you can like double spend, or you can mint, or you can print money, and nobody might be able to tell. So yeah, this is kind of terrifying. This is for the positive aspect is here, job security for us. But yeah, it makes us appreciate, I guess, the transparency of like older blockchains or older ways of doing things. And there's definitely kind of a trade-off when you add ZK to a project. You're losing transparency, and so you're making things more opaque, and you might make bugs more serious. But of course, ZK brings nice stuff, so it's a trade-off. And maybe I think this is my last slide on like insights and what's happening in the brain. But zkVMs are interesting because they're sort of like moving the bugs to the VM circuits, this layer. They create this abstraction layer, and then the user applications are sort of like built on top of a VM, and so the traditional ZK bugs or the ZK bugs that we're seeing are maybe not in that layer, unless they're doing some like low-level stuff and they're hinting and things like that. You could think that there should be less bugs and less interesting ZK bugs as more people move to these ZK VMs. And these ZK VMs have a lot of overhead, but it seems like they're getting they're getting better and better. And so, if I would try and predict things, I think more and more people are going to start writing for ZK VMs because it's probably easier and less prone to bugs. But people will, people always want to write the more optimized code, and people are always seeking optimizations. So I think there'll still be people who want to write circuits manually. Oh yeah, so are we out of business? I don't think so. I think part of the business might move to ZK VMs and either auditing more traditional apps on top of VMs, or the circuit for the VMs themselves, or the compilers, or we'll still have work with the people that want to write circuits. Okay, this slide is sort of the world I described is kind of dark and terrifying to some people. And so how would you, maybe some advice, like how would I react if I was part of a security team in some sort of a company working on some sort of ZK project? What I would do is that I would force every engineer around me to write specifications and make sure that we have documents that exactly explain what we're implementing. There's a lot of low-hanging fruits there, and so that's sort of the first layer of defense. Also use Rust or something like that. And then something I would do if I had a lot of money is that I would get several audits with different people. I think we've seen that in the past. Different auditors find different things. And so if you can afford it, it's good to have different pairs of eyes looking at your stuff. Don't get randoms to audit your code. We've seen a lot of random new auditing companies are starting to do these things, and they don't really have credibility, or we see middlemen that try to match you with people and you don't really know who you're getting. What I would say is just do some due diligence, ask people around, make sure that you're not giving money to people that don't really know what they're doing. Assuming that we know what we're doing, you can come to us, but it's for you to do your homework. And then the advice I give everyone is always, if you get an audit, always make sure that you have a very self-contained scope for the auditors. Make sure you're not overwhelming them with code, and that they can provide value to you. If your scope is too big, try to divide it into different projects. And yeah. And the last part, I think, is the more interesting part because it's my hot take of the moment. If you know bug bounties, like you put money somewhere, and whoever finds bugs can report the bugs, and you can pay them for these bugs. A lot of companies do that. I think Apple has like $1 million bounty. Maybe they've increased that price since then on the iPhone. And so you might think it's a good idea, but so the downside of bug bounties is that you're basically spending money incentivizing people to learn about your code base, and you're going to spend time triaging through bugs that are usually not great. So you waste a lot of time, you discard a lot of bugs. Sometimes you pay people for bugs that are not great. And the day they actually find a bug that is very good, they have to decide if they want to exploit it or if they want to report it. And of course, it's easier to report a bug because you're not going to get caught, you're doing things legally, and so on. But the thing is, if the reward you're giving them for reporting the bug is much lower than what they can make, they might not be incentivized to report the bug to you. And so, depending on the amount of money you're putting into these bug bounties, you might not be incentivizing the right things. You're basically training black hats to exploit your system. Funding them. Cool. So ZK security is a field, but it's also like the company we created. It's a generic name. generic name, but it's on purpose so that every time someone talks about ZK security, they talk about the company. So that's the idea. So now I'm going to go back to talk about the company just for a few slides. We don't just do audits. We also partnered with Zprice, and I'm actually currently judging the solutions that were submitted during Zprice. We do development work. Kata here was part of that actually as well. And I talked about Noname previously. And we also do research. ZK Bitcoin is one of the research stuff that we've done. I gave a talk at East Taipei last week on that. So you can just watch the replay if you want to learn more. And yeah, this is kind of a brag, but we've been auditing some projects with other big firms. And every time this happened, like every time, we found really bad bugs. You can check the blog for the reports and see the bugs we find. And the other firms didn't find anything. So I don't often brag about that, but I think it's good to brag about that. I think in a year of ZK security, we've managed to position ourselves pretty high in the list of auditors in the space. And yeah, so you should check our blog, and we publish everything we do, from technical articles to public reports and these kind of things. And we also hire. We are hiring. We have a hard time hiring. If you're interested in this field, please talk to me. We have the ZK Bank challenge. This is actually a bug that we found on the client like a month ago or 2 months ago, and it's like an exploitation of the GKR protocol. So if you're interested in crypto, in this kind of proof system bugs, and you're interested in GKR and these kind of things, you should look at the challenge. We had a lot of fun exploiting it and creating this challenge. And if you're interested in a job, of course, you should look at that as well. And I guess this is my final slide. We don't have too many followers on the Twitter account, so please follow it. And this is the blog if you're interested in whatever I talked about is in there. And that's it. Thanks.
Any questions for you? How to write a prospect? Like what did you see that people do right and what did you see people do wrong?
I'd say a specification is usually a document written in English. So I'm not talking about formal specifications, but just English specifications. And you need to be loadable enough. I guess the perfect test of the perfect specification is that if different people want to implement the same protocol, just by looking at the specification, they should be able to implement it, and their implementations should be interoperable, right? And usually this is also a good test to find bugs, is to have people try to implement the specification and see if they have something that matches. And then I have more hot takes on like how a specification should look like and the sections in it, and maybe CMI. I also wrote a tool that you can use. It's called Cargo Spec, and you can basically insert like special lines in your code, and the tool will extract the lines of specification from your code. So you can sort of mix code and specification. Cargo Spec, if you're interested. Yeah.
Hey, David. So the question I'm going to ask is probably one that you get all the time, but have you maybe tried like using an LLM and like feeding all the circuits, all your blocks into it and like fine tuning it just for doing these audits? Do you think that will probably scale well and be cheaper than like these traditional audits?
Yeah, I think that's a very good question. I think that's something that comes up every month internally. We're like, should we train or fine tune an LLM for that? We don't have too much. Like, I guess we have like training data, but it's not really in the right format. So we'd have to like do some work to like do stuff like that. Sometimes I do ask like Gemini or like ChatGPT, like, can you find a bug here and see if they find it, but they never find it. But maybe if we fine tune it, I mean, we'd have to fine tune it to really get good results. But we haven't really tried hard, and I'm really scared that AIs are gonna replace us. So we'll see in the next year. Yeah, if you're interested in working on that.
Yeah,
Good
I
project.
actually have like similar opinions with ChatGPT and Gemini, but I think Claude is doing a great job. The one that came out last month, that is great with finding vulnerabilities. But
Oh, which one is it?
the one by Anthropic, it's
Okay.
a new model. I think it's doing better than ChatGPT. It's called Claude.
Claude. Oh,
It's
Claude.
Claude. Yeah.
You're saying in French.
Oh,
I think it's a French name.
oh yeah.
Cool. Yeah.
I can just, okay, thanks. Do you see, I guess, like formal verification playing a role in ZK security in the future? And how do you think about that?
Okay, so that's a very good question because as I gave my talk, I was like, I didn't mention formal specification not even once, or maybe once. Yeah, I'd say so. I mean, I've given this hot take before, but I think formal verification is kind of like a dead end for most of what people do. If you're writing compilers and like custom gates like in Plonk, or like you have very specific problems, and these things are gonna get used by many people, then it's maybe worth trying to understand exactly if it's secure with like formal specs and proving these. But from what I've seen, a lot of these tools are just very hard to use, and so people just don't use them. They either don't use them or they try to use them and they get stuck and they give up. And so I would, if you're interested in that space, I would encourage people to work on like making these tools easier to use. But in the meantime, I don't think people are going to use them. And even when people use them, I've never heard of someone finding like a great bug with it. I think manual auditing of code is, or AIs might replace us, but otherwise manual auditing of code is here to stay, I think.
I have a question. So, like, for example, with Java, there was like a bug in quicksort for 20 years or something like that. So, what is the oldest bug you've found in CK, whether it's like in a code base or maybe a paper that was published several years ago or something like that?
Oh yeah, I mean, when you say that, comes to mind the Zcash bug that like they took a year to fix or something like that. I don't know if that's the oldest bug. I mean, that one was pretty bad because it was in production, and so when we audited it at the time, it was a very short audit, and I remember talking to them, and I don't know. Yeah, I guess we didn't find the bug also at the time, so that's interesting. And so that must have been the. I keep thinking about that bug. I think about that bug often. Yeah, but yeah, that's my answer.
Any other questions?
That's so much a question. I don't know. Well, I suppose it is. Thanks. Okay, so you talked about the economic incentives with bounties, for example. I mean, aren't you guys presumably faced with a lot of like the same like dilemma? I don't know. And is that like a part of like your role as an audit firm? Like you see a bug that could potentially drain like millions of people's, or let's say
Right.
millions of dollars worth of funds. I'm just wondering, do you guys have like what's the recourse for that if you don't expose it, or if someone on your team
Are you
goes
asking
about?
me if I ever thought about exploiting a bug that I found, or is that?
Well, I suppose like as the CEO of this company, how do you go about like reasoning with this if like someone on your team, let's say, doesn't disclose a very high value bug?
Yeah, so I feel like a lot of the, and yeah, good question again. I think a lot of the answer here is basically in the culture of the company and the culture. There's this like black hat, white hat kind of like cultures, and basically when you're a security firm, you're trying to, I don't know, you're trying to create a culture of like a white hat culture. Like we're here to like help the developers, we're here to help the client, and our role is really we're the good people, right? And I'm not trying to convince you, but we're always trying to create that culture internally. And so yeah, hopefully we never screen anyone during an interview and we end up hiring them and they end up being that kind of person. Like hopefully that never happens. There's always a chance, of course, right? And I guess part will be during the screening. The other part will be in like fostering this kind of culture and environment internally. But I don't know, we have another employee here. Kata, do you feel like you have to exploit the bugs? But yeah. Yeah, hopefully that never happens. I trust you, Kata.
All right. With that, thank you, David, so much.
All right, thanks.
So we'll do a 5-minute break, and then